Hello. Hello. Today we'll be discussing the structure of gold as I drew before for my own purpose. Gold Aurum 79. Let's put it like this. Aurum 79. 79 means that it has 79 protons, which means it also has 79 electrons, because proton is plus and electron is minus, and they're always equal in an atom. What it also has is neutrons. So let's draw here the neutrons, a cloud of neutrons. Imagine that this is 79 neutrons. I drew it quite small because the rest of the picture will be quite big. And we have also 79 protons here. Okay. And let's give you the formula for this orbitals: 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d. Actually, let's draw you the structure of orbitals. S means sphere. It's like this: 2 electrons. Sphere, 2 electrons. Next we have 2s, 2p. P would be like this. This would be a center. This would be electron. This would be electron. What we see that p orbital. This is a suborbital. This is a suborbital. But an orbital will have 6e, and it's quite easy to understand why it will have 6. We'll, let me draw you here. For example, this would be y-axis. This would be x-axis. And let me take a green marker. This would be z-axis. It's what we have in 3D structure. So we have x now. A p suborbital that has 2 atoms will be multiplied by the number of axes that we have in 3D. So here would be, with blue marker, also electrons. And y-axis. And also it will have a z-axis. Electron here, electron here. That would be 6. Okay, that is quite simple. Let's proceed. We'll have d orbitals that have 10 electrons. D orbitals. This would be p. Okay? D would have, if we have 2 atoms on one suborbital, it will have 5. Basically, it would be 1, 2, 3, 4, 5. This would be a d orbital. I draw it quite messy, but you understand. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 electrons. That would be a d orbital. And now for f orbital. And I'm sorry, but I will not be able to draw with these markers that I have the full amount of suborbitals on every orbital. So F would be 14 electrons. It would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This would be an F orbital. Let's put it like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 electrons. We have 40 electrons here. And this is not 2D. This is not 2D. This is 3D. You understand that? It's 3D. This structure that you have is quite easily understood if you have a 3D modeler that I'm planning to do right now. P orbital is quite easily understood, just 3 axes, 6 electrons. But this, they're between of them. And these are between of this. And what you need to know that all the electrons repel each other. They're the same minus sign, they all repel. So if you build this structure of 3D orbitals in a 3D editor, a 3D modeling program, it will be quite easy to understand. And let me show you what I have right here. Gold 79 protons and electrons, and here is the distance versus energy of the orbitals. You see S orbital, P orbital, the distance zeroes out while the energy grows. The outer orbitals have energy big, up energy big, but the distance, the faster the electron travels around the nucleus, and the faster it is, the far out it is, like around the Earth, that satellites travel around the Earth and on big speeds. So the energy of outer, like FD orbitals, will be bigger than P and F and S, but the distance to the core, look right here, I draw it again. This would be first S, this would be second S, and this would be everything that is quite closely positioned, like D, F, everything else, it will be quite close. This is the graph that shows you how it's. Okay, so now for more fresh stuff. Let's put this formula right here and draw the orbitals. And I'll show you again. S orbital is 2 electrons, P orbital is 6 electrons, D orbital is 10 electrons, and F orbital is 14 electrons. And this is all of the orbitals we need for gold. So, now, first S orbital. Let's put it on here. Here's electron, here's electron. Next, and these electrons have a different spin. This electron has, for example, 1 of the second spin, and this has minus 1 of the second spin. Half of this electron. This is what's called a spin. Next, we have 2s. S is a sphere. Let's draw it once again. S. And because we have electrons here, these electrons will be perpendicular to them. There will be one electron, a second electron, and their spins are opposite. And now you can see that we have a more close range electrons in the middle and more far out electrons outside, which makes us a rhomboid. And because of this rhomboid, this p orbital will be forced to have an eighth figure. If you think about that, it's very simple, but if you don't think about it, it's quite hard. But really, let's just draw this p orbital, this electron, and now for the p orbital we'll also have like on this picture we'll have 6 electrons. This would be another pair of electrons, like electron here, and now we're taking a green marker, and now we have 1, 2, 3, 4. We need 6 electrons, and this would be in z-axis. This would be 6 electrons. We now got to 2p electrons. Next would be, let's take a red marker. Outside would be, if we have it right here, maybe let's put like here and here. Here would be an electron. This would be 3s orbital. Okay, next we have 3p. If we have this like here, we'll have this would be an electron here, and now the same stuff for p. Will have we'll have electron here, and we'll also have electrons in the z-axis. This would be these electrons. The 3p, we covered the 3p. Next, 3d. And this is now becoming hard. 3d has 10 electrons. And I'm sorry, but I can't anymore draw with color markers because this 10 electron and 14 electron structure is so 3D, so complex that you can't draw it on paper, only view in 3D editor. So now I'll just take a gray marker and draw a 3D structure quite, chaotically. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons on a D, what's it called, 3D orbital. Okay, you got it? I understand you understand nothing from this drawing, but it's supposed to be viewed in 3D, because every electron repels each other and they must stay away as big distance as possible. Next, 4s. After that, because this structure is so complex, the next will be much simpler. So we draw an s orbital once again. If we have this electrons all over the way, maybe let's draw them like here. Here is E, here is E. It would be 4s orbital. And 2 electrons on an s orbital. And you also must understand one thing, that every time you add an electron to the structure, it starts repelling all of the electrons around it. So the structure will be unique, not just I drew here, just like electron here and electron here. It will be a unique balanced structure, For example, if you let me give you an example. If you put like 4 marbles in a sack, or you put 6 marbles or 5 marbles or 12 marbles in a sack, they will be balanced to their most possible balance, you know? So these electrons will be not like we draw here, but they will be very, very balanced. Next, we have 4p. Look here, we drew 4s. Next, we have 4p. What is this? This would be like this. 1, 2, this electron, this electron. Next, we take again for p a simple structure. We'll have this and this electron, and next we also have an x or z axis. We'll have 1, 2. We have electron here and electron here. This would be the 4p axis, which has 6 electrons, you know. Now, what we have next? We have 4p, 4d. We need to add 4d. And for d, for Christ's sake, it's 10 electrons. I'll draw it with a gray marker again. It's very complex to show on a paper. So 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. This would be 4d. This would be 4d. And we didn't even get now to 4f, which is 14 electrons. Next, 4d, 4f. Now we get to the 14 electrons. Now we have 4f. Let's draw it. 14 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This would be 4f. Let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 electrons we have here. This would be 4f, 14 electrons. Sorry, I drew it 2 times. 4f, 13 electrons. Okay. Next, what we have for gold, which is 79. 4f, 5s, and s would be simple, drawn with a red marker. After you have a very complex orbital, the next will be very simple. You know why? To preserve energy, because everything in this universe, it likes to preserve energy. So the next will be a simple, I'm not sure how they're composed like this in 3D space. That's why I'm building a 3D simulation of that. But for example, here will be 5s, 1 electron. Here will be electron 5s again. Just 2 electrons. Next, what we have? Next we have 5d and 5p and 5d. Okay, now 5p for gold. Okay, 5p. So we have electron here, it would be the first that we start is a cross like this, electron here, electron here. It's in red. Now we take blue across like this, 5, electron here, electron here. It's the second dimension, x, y, and now we have z. Now we have like this, electron here, electron here. You understand that because p orbital has 3 axes and 3 dimensions. So it's 2 multiplied by 3, which is 6. We got it. Now, this would be 5p orbital. This would be 5p. Okay, now for gold, we have just one last orbital left, which is 5d. And 5d is 10 electrons. I understand this stupid 2D drawing doesn't show much, but imagine it's 3D. So 10 electrons. Once again, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This would be the 1, 2, 3, 4, 5, 6, 7. It's not evenly drawn. 8, 9. Here, outside of our drawing area, would be 5d, 10 electrons. It's not ending in 5d, it's ending in 6s. You see here the number of electrons: 2, 4, 10, 12, 80, 28, 30, 36, 46, 60, 62, 68, 60, 78, and now for 6s we have 79 electrons, because this s has just one electron. It's not basically stable. For gold, it has just one 6s electron. So right now, I know that you will be seeing the future recordings that I include later being wrong, but right now we have here 78 electrons. We need a 79th electron. So we put another circle right here with here just one electron, that is 6s orbital. And it's just one electron. Okay, I will proceed to include other wrong information in the video after this, but you must remember there's also the 6s orbital. We, from the previous videos, were lacking one electron, and now I corrected that. I'm closing my pencil, and when you're watching this later, remember there's also 6s orbital, but with just one electron instead of 2. It's lacking one electron. Okay? Now proceed to watching the video. Thank you. Now, what we got here is 79 protons and electrons. If you look at the structure here with the dots, it's all of the 79 electrons of the structure of gold aurum. And you might ask yourself a question. You know that aurum is 79, right? And hydrogarum, which is mercury, would be 80. And for example, before aurum, platinum, Pt, would be 78 protons and electrons. You ask yourself a question. If we take one electron away, which is quite simple, from gold, will we get platinum or hydrogarum? Or for example, more interesting question. If we take cheap hydrogarum, mercury, and we take away one of its electrons, would we get gold? The answer is if you take hydrogarum 80 minus 1 electron, or is it plus? Let's see, 80 protons, 80 electrons, 79. You would get a hydrogarum ion, which, because we are taking away a minus structure, an electron, we will get a cation, which is plus cation of hydrogarum. But you will not get gold. Actually, the hydrogarum atom with plus sign is actually very close. A cation of hydrogarum is very close to gold. Close. But it's not gold. In order for you to get gold, you would need to change this protons. While the cation, the positive ion of hydrogarum, is very close to gold, it's not gold, because protons must be changed from 79 to, from 80 for hydrogarum to 79. You would need to take away one proton. And you know what that means? You know what that means? Taking away or adding a proton? I'll tell you, it means a nuke. It means a nuke. A thing that will explode half of the planet. You understand that? And that is what's called the philosopher's stone. That's what's called a philosopher's stone in alchemy. Alchemy was before chemistry. Al originates from Arabic al, chemistry, and that's a philosopher's stone question. Let's put it like this, question. And now we have an answer. To get gold aurum from hydrogarum mercury, you would need something they have in CERN in Switzerland, a nuclear reactor or a particle collider. It is possible to create now gold from mercury, but it takes a friggin' institution that is taking almost 3 countries to create that. You understand? It is possible to create several atoms of gold from, for example, mercury, or for example, from gold you could create more precious platinum. But it would need to take the powers of CERN Institute to create just a few atoms of that. You understand that? So now probably I answered your questions why at home with just mixing elements in a flask you cannot create gold. And it's not that I didn't try. I tried hard. I love to create gold, but it's just not at home. If you're not in CERN Institute, it's just not possible. Okay, that was about it. I'm sorry that this video wasn't too much ASMR. I planned it to be ASMR video for you to fall asleep. But now, thank you. Here, once again, the number of orbitals. Here is the distance of orbitals due to their energy. Here's s orbital, here's p orbital, here's t orbital, here's f orbital. The number of atoms in s is 2, in p is 6. I mean electrons, of course. I mean the number of electrons in s is 2, in p is 6, in d is 10, in f is 14. And there also A, B, C, D, E, F, there would be also H orbitals, I orbitals, G orbitals, for such things as lanthanoids and everything else that are very rarely visible even to scientists. So we just stop with F, or actually D for gold, okay? Because that's very complex molecules after that. And right now I'm planning to design this to be more simply understood. Let's put it like here, like 3D. I'm planning to create a simulation of that so that anyone can understand that, not just on paper like this, but in 3D simulation. Here once again you have your gold. 1s, 2s, 2p, 3s, 3p, 3d in gray, 4s, 4p, 4d, 4f in gray, again very complex, 5s in red, 5s, 5p in gray, all over the place, and 5d. And now something I forgot to tell before, you also need a 6s orbital, 6s orbital with just one electron instead of two. Just one electron instead of two electrons on the 6s orbital. I put it right here, 6s orbital. Okay, without one electron. And that's how you get your gold structure. And I explained it to you that you cannot just take one electron away from hydrogram 80, because that would create a hydrogram cation. But what you would need to do, which is actually very close to gold, this hydrogram 80 cation without one electron is very close to gold. That's why they use them in gold smelting. But to create real gold, you would need to take away one proton from cheap hydrogram, one proton, which is the nucleus. And that, my friend, would create a nuke. That's why you can only do that for a few atoms in things like CERN and proton colliders, very rare things to do, You can't do that at home. Okay, now I'm sorry if that was not a very ASMR experience for you, because I planned it to be a very ASMR experience, but at least I explained to you to what aurum gold 79 protons and electrons is. And once again, don't forget, from our last time we didn't include this, but it also has a 6s orbital with just one electron. Here, just 6s orbital with just one electron. Okay, now I thank you for learning physics and chemistry with me. Learn not just chemistry, but also learn physics yourself. And I hope that you learn it, and after that you will sleep peacefully. Thank you. Sleep peacefully. Learn physics, chemistry, and every science you can. And good night, my friend. Good night. Thank you.